these leaves of strobilanthes were just harvested and let to dry at the air. And then you see that they were turning blue. So inside of the plant there's a coloring matter, the hidden blue, and the enzyme which is transforming the matter onto the blue dye. So the hidden form of blue that you cannot see as blue on the leaves, we call it the precursor of indigo, which is the genuine name of the blue dye, the molecule. So we will be in a strange position of learning a bit of vocabulary of chemistry, biology, to enter in details. But that's very interesting because that's like learning any kind of new job, you have to learn the vocabulary. So inside of the fresh plant there are two different things, fresh indigo plant I mean. There's a precursor of the indigo, which is colorless, and the enzyme. So in some cases there are plenty of different enzymes depending on the plant, but then in some cases the enzyme is just doing the job during the drying process. So you see the blue molecule appearing, so the plant is kind of a mix of green from the chlorophyll and blue from the indigo appearing. It is also the case for the Persicaria tinctoria. It is turning a bit blue. But by repeated experimentations, I discovered that if I crush my leaves, Persicaria leaves, before I dry them, it is turning dramatically bluer. So, from all those experiments, I got the idea of a unique process, only one process for all the plants we can cultivate in Europe. So, for the world it was incredible. I just dried them, they did not turn blue at all. I did crush them very well before drying the made paste, and then it was turning dramatically blue. So one might think that, oh, the wood has much more blue in it than the Persicaria. But it is not true. If you crush the Persicaria fresh and dry it afterwards, it is turning the same. So that's very interesting. My only one process is based on this conclusion. So I will harvest my leaves, let them a couple of days in the shade for the water to evaporate a little bit, but not drying totally. So they turn a bit flexible with less water. Then I crush them and I dry them. So I have this beautiful compost here. So that's extremely interesting. It is not really a compost because it's a super quick thing, but it is equivalent of what people were doing in the past when doing the balls. They were crushing the leaves, so I agree totally, and then they were making piles, big piles of those balls for them to dry by the air, by just ambient atmosphere, because they had tons of that. But for us, it is very easy to crush the leaves, let them dry, even at small quantities. So that's interesting now to see that we can use all these matters, but don't think this is superior because there's a ball, the form of a ball. The form doesn't have any influence. The problem sometimes is that if you are not mastering that correctly, if you keep it in some humidity, getting kind of opinion that it must ferment, you might damage the content. So a big ball can be damaged inside because then it starts to rot. And I would not like to rot. So my best conclusion for all these processes detailed in the old text is that the very best is to let them half dry at the air, so to have less humidity in the leaves, and then crush them before they are dry, and aerate as much as you can. for this woad preparation, I was just putting that on a flat area to let it dry as quickly as possible, so it doesn't rot. There are two things in indigo plants. There's the indigo precursor, a kind of colorless thing, and the enzyme. So the enzyme is generating a kind of puzzle. It's kind of catalytic thing. So the enzyme is not involved in the blue. It is just kind of making the job of linking together those colorless little things, the precursors, and then they turn blue.